Welcome to the science lab class where we are going to study a course which is in electrical and electronic practical. Actually, we are going to do all the theory aspects for the semester online, and then when by God's grace we resume from this COVID-19 issues, we are going to enjoy the practical aspect. My name is Isaac Aipemensa from the Department of Electrical and Electronic Engineering, and therefore for the sake of email address you can contact me on any of them. But remember, when assignments are given, this is what you are supposed to use for your own assignment: electricalpractical.assignment@gmail.com, and this is the only telephone number I know. You can contact me anytime when you have questions to ask or any other thing. To begin with, we are going to look at the course outline for the semester. The first thing is Introduction to Basic Electronics. Then we'll move on to Electronic Workbench, where we are going to look at what it entails. Then we'll look at the tools and equipment needed for the practical. We'll also be looking at the electronic components we also need for this practical. Then we'll look at electronic circuits, do some electronic projects, which is 1 and 2. So the first thing is that we're supposed to introduce ourselves to the basics of electronics. Learning about this electronics and then creating your own project is a lot easier than you may think. In this lecture, I am going to give you a brief overview of the common electronic components and explain what their functions are. You will also learn about schematic diagrams and how they are going to be used in designing and building circuits. And finally, you put the information that you have been taught to create your own basic circuits and other projects. So when we say a workbench, what is a workbench all about? A workbench basically is a properly set up in a work area, which doesn't mean it has to be very fancy, even though, but it could be built by yourself. Then the next thing is electronic components. They can be very small, but it should portray that good idea. And then everything in the electronic workbench or the storage area must be well organized. So this is how an electronic workbench looks like. This is a storage area for the workbench, and then you can also store other things here. So this becomes your work area with your seats over here. Okay, so tools and equipment. When we say tools and equipment, they are the things we are going to use. They are the tools and equipment we are going to use, the things that we are going to use to make sure that we complete whatever task or electronic job we're going to do. So the first thing is breadboard. When you say breadboard, it is just like a circuit board where we are going to connect every component in order to make it complete. So when we say breadboard, they are essential tools for prototyping and building temporary circuits, and these boards contain holes for inserting wires and then other components, and we can use them temporarily without soldering them by joining them together with the help of either a sellotape or just by touching them to each other. But then to make it permanent, then we have to make sure we use the soldering iron. The next thing is the digital multimeter. We have a digital multimeter here, which we are going to use to measure resistances, to measure current, voltages, and etc. So we have two types of the multimeter. We have the digital and then the analog. So therefore, there can be an assignment which you have to differentiate between the digital and analog multimeters. So the next thing is the battery holder. We'll be using the battery holder. The battery holder is a plastic case that holds the batteries. Which batteries we are talking about represents the 9 volts to the AA types of the battery. Some holders are enclosed and we have an on and off switch built in it to control the flow of the power. Test leads, which are also called alligator clips. These are great connecting components together to test a circuit without the need of soldering. So when we are going to do or create our own circuit and we don't want to solder, we have these test clips or test leads or the alligator clips, which we can use to clip without soldering. Then we have the cutter or the wire cutter. We call it cutter. For these ones, they are very essential for stripping and then stranding the solid wires. What it means is that we can use this to peel the cables or the wires, and we can use this cutter type to also cut. At the same time, this can also be used to cut the wires. Precision screwdrivers. These are what we are going to use to make sure we unscrew and then screw a screw or a driver. So this is a screwdriver, and then it is going to help us to do all our screwing. Then we have jumper wire. Some people will say these are pieces of wires which are used on the breadboard to develop circuits, and then these are very solid wires. Jumper wires helps to make sure we can connect from one point to the another. So it serves as a link between two components. Soldering iron is what we are also going to use to solder a circuit to make it permanent. So when a circuit is supposed to be permanent, then we are going to use these ones called the soldering irons. Another thing you must note is the electronic component, and that one is the first one is the switch. The switch here makes and unmake a circuit, which means that the switch can be used to close or open a circuit. It can be used to turn on or turn off a circuit. A resistor. Resistors are used to resist the flow of current, as you know already in the various physics courses, be it the inter science or the general science. Resistors are there to make sure they reduce or they have an opposition on the flow of the current to control the voltage in the circuit. And then we are going to look more into that and then calculate and then determine the values of each resistor. We have another thing called the variable resistor, and another name for this variable resistor is the potentiometer. So variable resistors are known as potentiometers, and these components can be found in devices such as the light dimmer or the volume control in radios. So when you are playing your music, you turn the variable resistor or your tune or your volume button or whatever you may call it, either high or low, and this will have effect on the resistance of the line and at the same time have effect on your volume. Light dependent resistors. These are resistors which depend on light to control, or these are lights which depend on the types of some certain types of resistors to control their output. And the intensity of the light is being controlled by the resistance in the circuit. And then these are often in exterior lights, that is automatic control light. So the lights that you see on the street, example like the street light at dawn or at night, the light comes on, then when the darkness goes down, the light also goes off to turn off and then save energy. So we have what we call capacitors. Capacitors, they store electrical charges and then discharge them when needed. So the capacitor is just like a rechargeable battery, and it can be charged and then be discharged. The value is measured in farad, and then we can also measure the capacitance also in nanofarad this way, or in picofarad. So there are different ranges between which you can also measure them. A device that I always call my special device is the diode. It's an electronic component actually, and this diode allows electricity to flow in only one direction. So it's just like, as a man, if you are looking at only one direction, you would not have a lot of issues. But then if you have so many directions, then you conclude it in your house. So a diode is there to allow electricity flow in only one direction and blocks it from flowing in the opposite way. So therefore, this will also be used in constructing certain circuits to make sure that there is no feedback of current or electricity in the circuit. So therefore, it means that when we want the electricity to flow in the forward direction, it doesn't come when we test in the reverse direction. So we have to take note of that too. Then another thing you have to notice, the light emitting diode. That one, a lot of people might have seen it because it's everywhere, in your computers, in your TVs, TV remotes, whatever. We have the LEDs there, even your sockets, we have those LEDs there. And then these ones are standard diodes, in the fact that electrical current only flows in one direction. The main difference is that an LED will emit light when electricity flows through it. Inside an LED, there are two things there, which is the anode and then the cathode. The anode is the positive and then the cathode is the negative side of it. So you have to make sure that you never direct it in the opposite direction. The longer leg of the LED is the positive side, which is the anode. So most of the time you will see that we have this as the longer leg and then this is the shortest. This is the longer and then the short, the longer, the short. So as an engineer or as a scientist, you are supposed to make sure you know how to use the LED. Then another thing you have to note is the transistor. The transistor is a very tiny object that turns a current on or off when it is being triggered or when it is being switched on by electrical signal. In addition to being a switch, it can also be used as an amplifier in electronic circuits or electronic signals. So the transistor can also be used as an amplifier, and a transistor is similar to a relay except that it has no moving parts. So this is a relay, as we just mentioned. The relay here is an electrically operated switch that opens or closes when power is applied. Inside a relay is an electromagnetic switch that controls the mechanical switch. So like what we have in those TVs, that when you clap then the TV turns on, we can get a relay which will be doing the switching in there. So we get a microphone which will bring the sound, then the relay will also bring the light on or the TV on. So it turns that sound that it has received, or it receives the sound and then just switch to indicate that there has been a change, and when the change comes, it means the relay has been triggered. Integrated circuits, we normally call them the ICs. This is a circuit that has been reduced in size to fit inside a tiny chip. This circuit contains electronic components like the resistors and then the capacitors, but on a much smaller scale. Integrated circuits come in different various variations, such as the 555 timers, the voltage regulators, the microcontrollers, and many more, etc. Each pin on an IC has a unique term of function. So every pin, every pin you see over here, each of the pins you see here has its own job that it is also doing in the circuit. So before we bring today's class to an end, we want to get an overview of what a circuit is. A circuit is basically a closed path or an open path where conductivity of electrical current flows. So a closed circuit is like a circle because it starts from a point and ends at the same point, forming a complete loop. But then when we come to the open circuit, it starts at a point, then there's a break between them.